Lesson 1, vapor pressure. So let's look at what evaporation is. Evaporation is where molecules at the surface of liquid gain enough energy to overcome their intermolecular forces and change to gas. This causes pressure to build up above a liquid. So, vapor pressure is the pressure exerted by vapor or gas above a liquid at equilibrium. Liquid vapor equilibrium is basically some of the gas particles condense, and then we find both evaporating and condensing occurring at the same rate. So think of it when you are heating water in a pot and you put the lid on. The heat will heat up the water, causing it to turn into a gas, hitting the lid, then causing it to condense. So the rate of evaporation equals the rate of condensation. Boiling occurs when the vapor pressure becomes equal to or greater than the atmospheric pressure. At normal atmospheric pressure, we call this normal boiling point. Pressure does affect the boiling, so you have to think back to the fall when we talked about gases, and at higher altitudes such as Denver, Colorado, air pressure is much lower due to the decrease in the amount of air particles. Therefore, water will boil at a lower temperature and food takes longer to cook. At lower altitudes, the opposite is true. So boiling occurs when heat energy overcomes the attractive forces between the molecules. So the stronger the intermolecular forces, the higher the boiling point, and therefore it takes more energy to break the intermolecular forces of attraction between the particles. If we have weaker intermolecular forces, there's a lower boiling point. This takes less energy to break the forces of attraction between the particles. Evaporation occurs at the surface and boiling occurs throughout the sample. So think of this as a puddle on the sidewalk in the summer. It doesn't boil, but it will evaporate away, where here you have to add a heat source causing bubbles to form, causing it to rise through to create boiling. So the dotted line represents the normal boiling point. So here we are at 101.3 kilopascals. And at this point, we would have water boiling at 100 degrees Celsius. So what is the vapor pressure of ethanol at 40 degrees Celsius? Well, we find 40 degrees, find the line for ethanol, and go across, and it's about 17 kilopascal. So what's the boiling point of water at a pressure of 30 kilopascals? Here we would find 30 kilopascals, which is about 10, 20, 30. Follow this all the way over to water, and not there yet, not there yet. It's to be about 70 degrees Celsius. So now, using table H in your reference packet, what is the vapor pressure of propanol at 50 degrees Celsius?